Good evening and welcome to this webinar about the radioactive waste in Italy and in particular with the realization of the national repository that will allow the safe management of this waste in Italy. My name is Angelo Paratore. I work for Sogin, the Italian waste management organization. And let's look at something about Sogin. Sogin is the state-owned company that is responsible for the decommissioning and the waste management in Italy. As you know, probably the nuclear production in Italy was stopped in the 80s due to two referendums. And so now we have to manage our installations, nuclear power plants and fuel cycle facilities that were operated during those years. And we have also some activities in the nuclear fields, in institutional activities like research at industry and medicine in particular. So there is radioactive waste in Italy that have to be managed. And Sogin is the company responsible for the decommissioning of these installations and the management of the radioactive waste deriving from this decommissioning. And Sogin also is responsible and will be in charge also for the realization of a national repository that will be a facility, a surface facility dedicated to hosting long-term storage of intermediate high-level waste and for disposing of the very low-level and low-level waste. Sogin Group also is composed by a nuclear company that is responsible for the collection and the treatment of the institutional waste in Italy. The first question that you probably will ask about the radioactive waste in Italy is how much waste is in Italy today and how much waste will be generated in the future. This slide shows the overall foreseen quantities that will be managed in the next 40-50 years. The gray and the blue slices of the pie are the existing waste generated today by the blue one is the operations of the former shut down nuclear installations in the 60s, 70s and 80s, and the gray slice is the quantity of waste, the volume of waste deriving from past activities in the institutional field like industry, research and medicine. But additional waste will be generated in the future. We have to consider that radioactive waste production is not stopped in Italy, and we will generate waste mainly from the decommissioning of these installations and from the management of the resulting waste, and we will generate waste also from industry and medicine, hospitals, and from research. And so the orange slice of the pie is the waste deriving in the future from the decommissioning activities, and the yellow slice of the pie is the volume of waste deriving from the future institutional activities generated from the industry, research, and medicine activities. The overall quantity will be around 95,000 cubic meters, and it is of course, as I mentioned earlier, a forecast of the overall quantity to be generated in the future to be managed. The second question that you probably will ask is related to where this waste is today in Italy. And as you can see from the map here in this slide, the waste is divided into great subcategories. The green dots are the installations and the stores generally managed by Sogin in its site, and the gray dots are the stores facilities that are managed by other operators in Italy. So the gray operators, the gray dots in these slides, are the stores that are all around Italy, are collecting mainly institutional waste, usually very short-lived waste, that is waste that is decays in months or few years, and it can be managed by hospitals and other mainly medical installations, and can be later on managed as conventional waste. The largest quantity is connected to decommissioning activities. This is the green dots managed by Sogin. And this is the size of production, just like the new power plants in Caorso, Torino, Latina, and Carigliano, and the fuel cycle facilities that were managed by Enea in the past and now are managed by Sogin. The third question that you probably will ask is, how are these wastes managed until disposal? So we must take into account that waste, the classification of waste. So waste is classified in Italy according also to the IAEA classification in very short-lived waste, that is waste that contains very short-lived radionuclides and decays to clearance in few years. So it can be managed by the operators until disposal, being managed as and disposed as conventional waste. So the very low level waste and low level waste that are generated contains greater quantities of long-lived radionuclides, and mainly short-lived radionuclides. They have to be managed accordingly, and they have to be can be disposed of in near-surface repository. But pending the availability of the national repository in Italy, they are currently stored in the Sogin and other institutional storage facilities. The last classification is the intermediate level waste and high level waste. This is waste that contain higher quantities of longer-lived radionuclides and cannot be disposed of in surface, and they have to be disposed of in deeper and geological repositories. So this intermediate level waste and high level waste contain, just like spent nuclear fuel, for example, are temporarily stored in the Sogin sites and in the fuel cycle facilities, storage facilities, and are pending the availability of the national repository, where this waste will be long-term stored, waiting for the availability of a geological repository, so a deep geological repository. So the overall indication about this slide is that the national repository will host two different facilities. One is for the disposal of near-surface disposal of very low-level and low-level waste, and the second is a facility for long-term storage of intermediate-level waste and high-level waste. So, talking about the realization of the national repository, we have to refer to the one legislative decree in Italy, that is number 31 of 2010, that foresees the issue of a national map of potentially suitable areas. That is, we will show you in the next slides how this map is derived. And this map was, the criteria for deriving this map were issued in 2014 by the ISPRA, the former regulatory authority in Italy. According to these criteria, the Sogin derived the national map of potentially suitable areas in 2015 and made it available to ministries, that from 2015 to 2021 they reviewed together with the regulatory authority the map. The map was also reviewed several times due to change in the databases on which it was released. And finally, on January the 5th this year, 2021, the national map was formally authorized for publication and is now published in the Sogin website dedicated to the National Repository. After publication of the map, the consultation phase is started, and is showed in the slide with this blue line. We are here right now. The public consultation phase consists in 180 days of gathering possible observations and comments by the stakeholders in Italy, involved stakeholders, and in the additional 60 days for an overall duration of 240 days, ending with what we call national seminar or national workshop, where all the involved stakeholders will be gathered to discuss all the questions, all possible observations regarding the repository, regarding the siting, regarding the benefits to the territory, and regarding the safety and all issues. And after this seminar, in additional 30 days, the map will be updated, and so what we call national map of suitable areas. We missed the potentially adjective, and so this map will be sent to the competent ministries for approval. After this approval of the map of the suitable areas, we'll start what we call the consultation phase, what we call the collection of expressions of interest. So this is the volunteer phase, because I recall you that the process in Italy is what we call mixed mode approach, mixing together a technical approach and a volunteer and an approach aimed at the consultation and the public consultation for the expression of interests. So in this mixed mode approach, in this second phase, we will collect the possible expression of interest. We will strive to get expression of interest from territories for hosting the repository. And we will examine this expression of interest and in case of no expression of interest, we will start to strive with bilateral discussions and negotiation phase in order to collect possible expressions. And we will have at least one expression of interest in one area. We'll start what we call investigation phase, that is aimed at investigating locally in the territories of these suitable areas, investigating the sites, potential sites, and will, after investigating and having collected data about this potential site, there will be what we call siting criteria, siting decree, and the site will be selected. We will start local investigation on this particular site, and we'll start also the design phase, the executive design phase of the repository, and that will start the construction phase and then the operation phase of the repository itself. The consultation phase is, as I mentioned earlier, is quite important and quite unique in the framework, in the Italian framework. We will have established 3 possible channels for participating to this consultancy. As consultation. Sorry, this is the first one. The first channel is the site itself. This is a dedicated website where you can find frequently asked questions. You can find informative pages that explain the content of the documents. You can find around 300 documents regarding the siting and the design of the repository. and you can access this document. You can look in detail in the map, and you can go drilling down with the geographic information system to enlarge the suitable areas to look in particular on these suitable areas. And this is the first channel. The second channel is the email address, where you can address particular questions, observations, and comments that you can have on this consultation phase, and they will be answered by Sogin in due time. The last, probably most important channel for the consultation phase is the website and the possibility of presenting proposals and observations to the documents through this channel. And as I will show you in the next slide, you can present observation on the design, on the siting, on the map, and so that will be subject to discussion during the national seminar. The two possibilities that you have for presenting these proposals and observations to the documents published in the website are the web application itself, that is suited and quite user-friendly for submitting this proposal and observations in the 180 days, as I mentioned before. And there is also certified email where you can send observations and comments that will be considered by Sogin for the next revision of the map after the public workshop, public seminar. Let's have a look right now at the siting criteria. I mentioned earlier that were issued by the regulatory authority in 2014. The siting criteria are published in Technical Guide 29 that was issued in 2014 by the former regulatory authority, and where two categories of criteria are defined for defining the national map. The first category is the exclusion criteria. We have 15 exclusion criteria. Are criteria that are based mainly on consideration on safety items and safety considerations that are recommended by IAA. So we have, for example, geological and geomorphologic and hydraulic stability of the area that must be present in order to assure the safety performance of the engineering structures to be realized by means of multiple artificial barriers. There are also the other consideration is the radioactive waste confinement by natural barriers provided by the hydrogeological and chemical characteristics of the soil in order to prevent possible release of radionuclides into the biosphere. Another consideration is the disposal facility construction that has to be done in respect of existing regulatory constraints in the fields of environmental protection and conservation of natural and cultural resources. The one thing that IAA recommends is also taking into account the isolation of the disposal facility from anthropic infrastructures and from human activities, taking into account the mutual impact arising from the presence of disposal facility and the transport of the radioactive waste. Last but not less important is the isolation of the disposal facility from natural subsoil resources and the protection against extreme weather conditions. So according to these recommendations and general criteria, we derived, the regulatory authority derived the exclusion criteria. Exclusion criteria is this 15 criteria that are mainly aimed at safety. So, like For example, let's look at the exclusion criteria number 1. We have the presence of active or quiescent volcanoes. It's quite self-explaining. And exclusion criteria number 2 leads to the exclusion of areas with a high seismic activity and characterized by, for example, by a peak ground horizontal acceleration equal or greater than 0.25 g. The exclusion criteria number 3 excludes areas interested by superficial faulting. The number 4 excludes areas characterized by geomorphological and or hydraulic risk, like flooding or landsliding. The exclusion criteria number 5 excludes areas whose alluvial deposits testifies floodings happened in the Holocene geological era starting around 12,000 years ago, and in this way is an additional precautionary criterion referred to hydraulic risk in the future. The exclusion criteria number 6 excludes areas located above 700 meters above sea level, because this is an altitude where orography becomes more complex and more structured, and slopes are steeper and rainfall are more abundant. The exclusion criteria number 7 excludes areas characterized by an average slope greater than 10%, because these slopes could expose the facility to surface erosion, transport and sedimentation phenomena. Number 8, areas are excluded within 5 kilometers from the coastline or located above 20 meters above sea level. And these areas can be subject to marine ingression and corrosive effects due to the marine climate impacting on their resistance to degradation of the disposal facility structure. Exclusion criteria number 8 exclude areas interested by morphogenetic karst processes or with presence of skin holes, since they are subject to potential collapse of the walls. The number 10 is again, it's quite self-explaining, because water tables close to the surface can reduce the isolation rate of the disposal facility and facilitate the radionuclides transfer into the biosphere. The number 11 excludes areas insisting on national or regional parks, natural reserves, oases, geoparks, and so on. And the number 12 excludes area at an unsuitable distance from residential zones, mainly to prevent possible interferences of the human activities during the operations phase of the repository, taking into account also the expected future development of the zone itself. The exclusion criteria 13 excludes area within a distance of 1 kilometer from main transport routes, taking into account the potential impact of transport accidents on the disposal facility. This is important, because it's not an impact of the repository, but it is impact of the transport lines and possible accidents on the repository. The number 14 excludes areas with no presence of underground resources, which may result in future settlements of human activities after closure of the repository, so in this way compromising the isolation of the disposal facility. And the last one, the 15, excludes area with industrial activities which could be subject to major accidents impacting on the repository itself. So, sorry for this long explanation, but I think it was important to go in detail on the exclusion criteria. The next one is the, I hope, shorter explanation of the investigation criteria that, as I mentioned earlier, are criteria that have been established by the authority in order to investigate, again, on a national basis, available data basis, the territories that were not excluded by the application of the exclusion criteria. So the investigation criteria, very quickly, are the number 1 is self-explaining again, and is what was not excluded under exclusion criteria number 1. And the number 2 is the presence of significant vertical movements that are linked to phenomena that are linked to natural causes of geological or anthropogenic nature. The investigation criteria number 3 is geological morphostructural setting, and so this aspect affects the geological technical modeling required for the evaluation of the disposal facility. The number 4 is the presence of endorheic type river basins. These are basins that have no outflowing river and could constitute a convergence point for the surface hydrographic network. And so in case of intense rainfall, the deepest point of these basins can become subject to water stagnation. The number 5 is the presence of accelerated erosion phenomena. It's quite self-explaining. The number 6 is connected to the weather and climatic conditions. It refers to rainfall, snowfalls, and extreme events. Number 7 is physical and mechanical parameters of the soil. These features refer in particular to the capacity of the soil for bearing loads and the susceptibility to liquefaction phenomena. The number 8 is hydrogeological parameters. This is quite important criterion. This refers to hydrogeologic characteristics like distance of piezometric levels from the near surface level and from the foundation of the facility, distance from springs and other water collection points, and use of water for direct or indirect or human nutrition scopes. So this is a criterion connected to the presence of water that is, as you know, probably an enemy of the safe disposal of waste. The number 9 is chemical parameters of soil and groundwater. This criterion provides information on the effectiveness of the ground to limit the transfer of radionuclides in the groundwater. The number 10 is referred to the habitats, animal and plant species, and conservation importance. And in addition to exclusion criteria number 11, it puts into evidence the presence of endangered species reported in available databases. The number 11, the agriculture production and of outstanding quality, is again a self-explaining criterion. Number 12, the availability of primary transport infrastructures, for example, highways and suburban roads and railways lines, and allows to connected to the easy possibility of reaching the repository from available transport routes. The last one is the presence of relevant or strategic critical infrastructures, and refers to the possible mutual impact. Again, mutual impact arising from the proximity of critical or strategic infrastructures. So, sorry for this long description of the criteria that I believe was important to let you know how the map was derived. And this is the slide showing the actual phases for deriving the map. We started with this first phase where they started from the overall national territory, and applying the exclusion criteria, we derived the national and part of the investigation criteria. We derived the national map of potentially suitable areas. That is the green map showed in the picture. And as I mentioned, we will have a national seminar where we will discuss this map, and we will start the consultation. We will start the volunteer phase for collecting the expression of interest. And so in this phase, we will also will focus on the possible suitable sites. Now we speak about sites, no more areas, and that will be identified within the areas selected in phase 1. The last phase is that is shown in this slide is the the phase where areas with agreement will be technically investigated for selecting specific sites and arriving to the chosen site that will be the site that will be qualified for hosting the national repository. How are the criteria applied? As probably you understood from the previous slides, we start from this regional mapping phase that is defined by IAA, where areas are excluded based on the available data and available data that show non-compliance of the territory for safety reasons. And then the site screening phase, where areas are excluded or are ranked, as I will show you later on, according to more defined data compared to the investigation criteria defined by the regulatory authority. On this video here shows how actually the exclusion criteria and the citing criteria work. We have here on this map the brown area territory that is suitable, and the excluded by the first criterion, the blue excluded areas. Then we apply a second and a third criterion. A second criterion excludes more blue areas, leaving only reduced quantity of brown territory, suitable territory. And then we, with subsequent application of criteria, we are excluding more and more areas, the blue areas, leaving less brown suitable territories. And finally, with the application of the last criteria, we have all this blue excluded area and few left green suitable areas. We have to underline that areas are also vast portion of territory. We have favorable characteristics for hosting the repository, where we have to look for specific sites. From the application of this criteria, we finally arrive to what we call National Map of Potentially Suitable Areas that was published on January the 5th this year, that collects 67 potentially suitable areas in 7 regions. We have 8 potentially suitable areas in the Piedmont region, 24 areas in the Lazio Tuscany areas, and in the middle also, and 17 areas in Basilicata and the Puglia regions, 4 areas in Sicily, and 14 areas in Sardinia. We were required by law to derive what we call suitability order, to rank the areas in a suitability order. This is a specific requirement by law, and we derived and we elaborated a proposal that has been published and will be discussed during the consultation phase and during the seminar. This proposal considers, first of all, that these 67 potentially suitable areas are completely equal in terms of respect of the rigid safety criteria of the Technical Guide 29. So we classified these areas taking into account some criteria from the exclusion and the investigation criteria, mainly connected to technical, social and economic aspects. So we consider, for example, criteria like the maritime and terrestrial transports. It's quite logic to think that maritime and sea transports to islands like Sicily and Sardinia are more complicated and economically more expensive than terrestrial transports. So this is the transports was one of the criteria that was considered for ranking in this suitability orders the area. The regional seismicity that defined by regions is another criterion that was considered for ranking the areas, or distance from near towns. So in connection with the mutual impact of the repository with the territories. and the presence of valuable cultivations and natural resources. So we ranked the 67 areas in these four categories. The first is what we call highly favorable. A1 contains 12 areas, and the second category in this ranking contains 11 areas, is the A2, and in the B category contains 15 areas, is the insular areas, as I mentioned, in connection with the difficulty with the transport. And the last category contains 29 areas in connection with the seismic zone 2 defined by regions, in connection with the more difficult management of the territory in case of seismic events. Let's have a look right now to the design of the repository. We have Sogin had issued a preliminary design of the repository that is this must be correctly said, that is preliminary, is more a concept design more than a preliminary design, due to the fact that we do not know the site where the repository will be realized, because we are in the consultation phase. So not knowing the area where the repository will be realized, the design is necessarily preliminary in terms of concept layout. You see in this slide a generic and general layout of the repository. This is surrounded, is square shaped, but we do not can rely on this final shape of the repository, because this will be decided in connection with the shape and the orography of the territory that will host the repository. On the left side, you can see the green large area that is dedicated to the national repository, while the right area, the white area, is dedicated to the technology park. I will tell you something more later on. The area number 1 is dedicated to hosting the disposal of radio level and low level waste, and then area number 2 is dedicated to hosting the long-term storage of intermediate level waste and high level waste. It's for similar buildings. The area number 3 is the cell production, the area dedicated to host materials for cell production. The area number 4 is the module production plant. The area number 5 is the module loading plant, where the modules are loaded with waste. And the plant number 6 is the solid waste treatment plant, while the number 7 is the quality control plant for radiochemical analysis. Some additional words about the technology park. It is a large facility hosting research laboratories dedicated to radiochemical analysis. They're dedicated, to R&D, to research and developments devoted to decommissioning and waste management, as well as sustainable development activities to be agreed with the territories that will volunteer for hosting the repository. How does the repository work in terms of isolation of the waste themselves from the environment? We will have 4 barriers, or what we call multiple barrier systems. It is constituted by the waste package itself. There is a waste package where the waste is isolated by conditioning process with, for example, qualified grouting. And the second barrier is the module, where 6 drums or 1 or 2 prismatic containers will be inserted and will be grouted with qualified grout designed for a duration of more than 300 years. And the module so composed will be inserted in what we call vault. The vault will contain 240 modules, and the modules will be separated by gravel, by inert material for isolation and for structural resistance of the modules themselves. 90 volts will be the overall capacity of the disposal facility of the National Repository. And these vaults, when completely filled by modules, will be covered by a multi-layer cover that will isolate the repository from weather conditions, from weather events, from rainfalls during the almost 3 centuries that are needed for the decay of the low-level waste, for the short-lived radionuclides contained in the low-level waste to decay under clearance level and to decay in order to finally release the site for unconventional release. We have to say that the final concentration will not be under clearance level, but will be so low that the impact on the territories and on the environment will be negligible in comparison with the effects of natural radioactivity. Now we have this is a map showing one of the 4 buildings dedicated to long-term storage of intermediate level waste and high level waste. In particular, this building, the 4 buildings are quite similar. This is the only building different from the other 3 due to this vault that hosts the cask and high integrity container for the spent nuclear fuel and for the residues from reprocessing. The other 3 vaults are dedicated to long-term storage of intermediate level waste in high integrity container. This is a section of the map of the building hosting the high level waste. This is what we call storage hall or a 4 cask storage hall. The cask is one high integrity container shown on the right of this picture, where the high level residues are contained, are stored, and the cask is what we call dual purpose container, in the sense that is qualified both for transport and for storage. So these high integrity containers relies with the special cast iron are stored in vertical position, in this case in the storage hall, and they are moved just in case of possible leakage. And for possible maintenance, we designed a hot cell that is shown on the right, where the cask can be loaded and opened for substituting the leak tightness, for substituting the equipment for assuring the leak tightness of the cask during the storage period. So now let's have a look at what we call Technology Park. The National Repository will be realized within a technology park that is a center of excellence for advanced research and development on nuclear matters and sustainable development. And the park will have structures dedicated to information and training, and it will support also local communities, bringing added value to the territory. Why added value? Because the laboratories will be on the new technologies for decommissioning and waste management, for example, but also laboratories for environmental analysis and research laboratories for sustainable development to be agreed with the hosting communities during the site selection phase. The Technology Park will also visitor centers and other facilities that are in common with the National Repository. The benefits for the hosting communities are defined and established by the Decree number 31, and they are aimed to economic benefits for local communities, like tax reductions, that they will be proposed and agreed during the consultation phase. But additional benefits will derive by the occupational workforce during the various phases of the National Repository and Technology Park life cycle. I recall you 300 years life cycle. So we envisage an average of 2,000 direct jobs per year during the 4 years construction, and around 700 employees during the operational phase that will last around 40-50 years. These numbers can increase due to the indirect jobs created in the areas and to the long-term social and economic added value in the hosting region. For example, in connection with the communication routes and transport media and ancillary services. So we are now to the end of our webinar. I thank you all very much for your kind attention and suggest you to visit our website and to answer questions or comments. We will answer as soon as possible. And so thanks again to you all, and good luck.